teenagers, gather around as we gear up for the ultimate battle of programming chaos. And in the left corner we have the heavyweight champion, the backbone of enterprise software, the tool that has powered millions of applications. Please welcome C#.
But wait, in the red corner we have another competitor. It's with its concise syntax, mathematical elegance, and immutable data structures. It's been making waves and winning hearts. Please welcome F#.
Just a second. So, my name is Max Arshinov. Currently I shape solutions at EPAM Spain, and I have to confess I'm in love with both languages. However, F# has never been my primary tool, and I doubt that it'll become one someday.
And I'm Vagif Abilov. I work for a Norwegian company Miles in Oslo. And I'm so old that I even programmed Fortran using punch cards in the university. But last years I've been focusing on functional programming and F# in particular. And I choose F# because of its algebraic data structures, immutability by default, and powerful features like computation expressions.
And I choose C# because of three main factors. First of all, C# is a mainstream feature-rich language. Secondly, it's extremely versatile. And last but not least, I lack convincing arguments to replace C# with something else.
So both languages are going to battle for your votes. Both are .NET languages. They run on .NET runtime. Both of them quite pragmatic, and actually both supports multi-paradigms. C# has evolved quite a lot, and it gradually started accepting functional concepts. But F# hasn't changed that much since its introduction in 2005. But from the very beginning, you could also do object-oriented programming using F#.
Let's explore the strengths and weaknesses of each language without bias. Please consider our discussion today and vote based on the discussion rather than your personal preferences. By the end of the talk, we are going to identify the winner, and you are judges today. Vagif, if C# wins today, would you consider switch back to it from F#?
I don't think so. I've used them both. I think I've made my choice. But I'm thrilled to know what the audience means, what are the preferences of people who are going to vote.
Sure, let's get familiar with you guys. And let's learn how to vote. This one, not for scoring, just to check how many of C# people are in the room. Who are you? Are you a C# person or F# person or both? Yeah, you're like super smart. You saw the QR code.
Mm-hmm.
Okay.
Yeah,
it's gonna be a tough one.
There's full audience of C# people.
Yeah,
It will be hard time for me, but I will try to do my best, and I hope you will stay fair judges.
Sure. So hopefully everyone had enough time to get familiar with the voting procedure. So let's begin our first round. And it is about differences in type systems of the languages. So C# is an object-oriented first language, and it's quite common to design your business logic with classes and interfaces.
And in functional programming, we are using so-called algebraic data types. It's product types and sum types. And product types are quite similar in both languages. You have classes, you have records, structs. So we'll focus on the difference between them, and that will be sum type. It's a type that is used to combine mutually exclusive cases.
But classes and interfaces first. We are going to be using an e-commerce solution example throughout our presentation, mainly because we presume that you are familiar with this domain, either as developers or consumers. So these kind of systems, they usually have some advanced notification capabilities, and it's quite common to trigger the notifications using domain events. So what I would do is I can create a shared interface like iDomain event, and then I can create classes like order placed, order, let me check, I don't have any screen here, yeah, order paid, order shipped. So all these classes, they implement the same interface.
And this looks very familiar to me. This is how I was programming in C# years ago. And, but today I find this rather verbose. First, all these classes, they implement a certain interface. You must specify that. Then you have like visibility. You need to specify access, whether it's public or private. And then you also have constructors, after all. So it's just too many details to me.
Okay, but I think that this example is a bit outdated. Since C#9, it is possible to replace classes with records, and if the syntax verbosity is the only thing that bothers you, I think that records can be a workaround. So is it any better right now?
Yeah, this actually looks almost like in F#, much more compact. Still, difference is that they need to implement interfaces. It's not how we do it in F#.
Yeah, and that's because we stole records from F#. And how do you do things in F#?
Well, in F#, here you see a couple of types. One, it's a product type, it's a record. And underneath you see so-called discriminated union. It's a sum type. So we need to define certain events. And then you just define it in this type. Everything is described here. Event can refer to some record, or if event is very simple, like here, you don't even need to bring some other types. It will be just a tuple here. So, and I find this much more concise, and like the model is much more tight.
Okay, I have a question here about the event payload type. So it looks like that it's quite rigid. Each time I need to add a new event, I need to modify the event payload class. So I'm thinking about the open-close principle, which states that program entities should be closed for modifications, but open for extensions, which is not the case here, because to me, this class is effectively closed for both modifications and extensions, and this looks like a downside to me.
Yeah, this is actually an important point, an important difference. And if you are working on a public class library, then interface is the way to go. But those of you who went to Kevin Henny's talk yesterday about data structures, there was one slide where he said, don't publish interfaces inside the team. So I believe that if the team controls code base, then you will be better off without like opening things for extension outside, actually having all domain closed. It will give you some advantages.
But why? Why do you want to do it?
Exhaustive pattern matching. So if you have your code where you need to pattern match and do certain things depending on type of event, if you have interfaces, you don't really know how many implementations you have. With this, as I mentioned, this model is tight. So you sort of closed it, and then you will get compiler warning or error if you don't match all cases.
Well, I'm not sure that I'm convinced, because what I see here is another way of doing things that I can do in C#. It's not worse, but it is not any better. It's different, more functional, yes, but kind of the same.
Yeah, we just have different opinions here, but I think I have a proof that C# community actually needs unions. So some of you probably familiar with this NuGet package. It's one-off. It has almost 14 million downloads. So it's just an additional library which comes with some sort of alternative in C# to implement discriminated unions. So it clearly shows that developers need that.
Okay, and how many of you guys are familiar with this library? Okay, quite a few.
Hands, yeah.
So just in case, so what it does basically, it's a generic class with up to 30 generic parameters that you can fill up with your types. And then, since we don't have any support for exhausting pattern matching in C#, we can emulate it with a method like this one. And this is exhaustive. Well, it's implemented differently, but as a method, not as a language keyword or something. But we do the same. the same thing.
Yeah, it's a great library. It has its own limitations. It supports up to 31 cases, and actually you can have a large system, much more events. Also, it generates a lot of internal code for each case, so it doesn't really look like a real 100% replacement for discriminated union to me.
Well, I agree. Yeah, one of is more a plaster on the sore rather than a proper implementation. But discriminated unions are actually coming to F#. So the proposal had been originally scheduled for C#10, but then more implementation options appeared.
Yeah, and then it was C#11, C#12, and then when will it going to be released? C#20?
Okay, last week I had an opportunity to talk, to speak with Matt Sorgerson, who's a lead designer and architect of the C# language. So according to Matt, it's C#14 plus-ish, but they will really implement it someday. And yeah, I know how it sounds, but discriminated unions would be a groundbreaking change for the C# type system. So I think that we should wait a little bit and give the language team some time to do the proper implementation.
Sure, fair enough. And I agree it will be a game changer in C#. It's a really important addition. But let's have another vote then. And today we are where we are.
Sure. So do we desperately lack discriminated unions in C# type system? Is it something you struggle with? No, I'm good with what we have in C#. Yes.
Okay, changing a little. Yeah, still majority for. Okay, getting closer.
It's getting more interesting. Yeah.
Yeah.
Pretty close.
Okay, so
yeah,
I guess
it was close enough.
That. But yeah, it's actually relatively close. So I'm glad that I have understanding in C# community for that.
No, still not enough, but it was really close. Yeah.
It was actually very close. Okay.
Yeah. So 1-0. Let's move on. Round 2: data model and operations.
Okay. So this is how I was learning. Actually, I was learning C++. It was before C#. And this is how in universities they teach C#, Java these days. Like you have a class, and then you define some data on that, and also operations on that. But later, I drifted towards a different approach where I was working just with pure data structures, and all data processing were encapsulated in other classes, like some sort of managers. And but I think classical OP actually leans towards the scenario example on the left-hand side. So doesn't it create some sort of confusion? And you have two schools.
I think that we are overlooking the versatility that C# offers. The fact that we have multiple options is not a bad thing. It does not necessarily make C# inferior. It just enables a wider variety of programming styles and preferences. So I think that's fine. Some people would prefer the left side, some people would prefer the right side.
What concerns me is that technology leaders of OP, they condemn separating data and operations. So people are driven towards mixing them. And this is, I find, both confusing and basically wrong.
Oh, well, yes and no. First of all, that's quite an old quote from Martin Fowler, and he referred to Java. So, yeah, it's similar to C#, but there are differences. And yes, community is kind of divided, especially in the DDD community, with some viewing the anemic domain model as an anti-pattern, while others seeing it as a straightforward, solid-driven implementation. But on the other hand, this is kind of decision you only need to make once. Over time, I learned how to adapt to different preferences with different teams. So what I would do, I would just talk to the team and discuss which one they prefer, and we'll just establish the boundaries and we'll follow the rules that we established.
And if you have two senior architects with different preferences, they will probably fight like we are doing now. But in functional programming, our choices are easier. Default choice just not to mix data and operation. And I wholeheartedly agree with late Joe Armstrong that those are two different animals to put them in one cage, and you will get, again, I use the word tight model if you separate your data, immutable data, and put operations in different place.
Okay, so how do you do things in F#?
So this is an example of how we do it in F#. We are defining here our data. In this case, it's discriminated union. And then we put operations typically in some module where we define what can be done to this data. And here how we use this module. This is our order processing pipeline. So you see we have both data and operations combined in this pipeline. So it looks quite separated.
But what about the dependencies like databases or third-party services? Aren't you oversimplifying this example?
Yes, I am oversimplifying, but I did it for clarity because it doesn't really change the structure of the code. You bootstrap the code, you send your dependencies, data access, functions, but it will be still the same. Data on one side and operations on the other.
Okay, I'll believe you. So let's summarize this round. C# tends to combine data models and operations together. I still think that that's good. And regarding the dynamic domain model, well, different projects have different requirements. So dynamic domain model might be a good fit for simple CRUD applications, while a rich domain model might be a better fit for more complex applications.
And I believe in functional programming you get cleaner code, cleaner data structure definitions, which will eventually make it easier to maintain and extend.
Okay, so what do you prefer? Data structures and functions should be bound together, a vote to C#, or we need to separate them?
Yeah, we usually have very close in this round. Aha. First point to F#. Wow.
Is it to F#? Oh, yeah.
Let's give it a few more seconds. Okay, what is the score?
1-1. We are even. Let's continue then. So, round 3. Polymorphism versus pattern matching. So our aim here is to compare two well-known techniques that both help make code more expressive and maintainable. Let's start with polymorphism. That's one of the cornerstones of the object-oriented programming, and it's quite common to have a shared interface like this one, iPayment, and I can have multiple implementations of this interface, such as card payment or bank payment. And the beauty of this example is that a developer doesn't need to know the implementation details. They would rather code against the abstraction, which is iPayment interface in this case.
Mm-hmm. So the main idea is that you can write generic code which is not concerned about what concrete types you're using, right?
Yes, yes, exactly. And we even, in the object-oriented programming world, we even have some principles. LSP, list of substitution principle, requires that superclasses can be substituted with subclasses without affecting the program correctness. And this is how we make sure that polymorphism actually works as intended.
Mm-hmm. Yeah, list substitution principle is used to verify that you have truly polymorphic class hierarchy. And I think that in this competition it's actually on my side, because I've seen in very many projects that developers violate LSP all the time. Like here, let's say we extend our system with cash payment. Now we accept pay on delivery, which means that if we need to implement a method that check if order can be delivered, it used to check that payment is completed, because if it's a bank or card payment, you need to run payment through. But now you can order something and then pay when courier comes. And so what developers typically do, they will just check that it is a cash payment, then you don't need to check its state. So it's a clear violation of Liskov substitution principle, and this is what makes me uncomfortable of using this approach.
I have a lot to say here. First of all, this is an example that you carefully crafted to support your point of view.
Yeah.
You could have modified your interface. You could have introduced another interface just to preserve polymorphism, but you decided what to do upcasting. Okay, polymorphism sucks, which is not the case. It could have been implemented differently, and additionally, you just introduced a new business requirement, and it's quite common to do revisions of your code base from time to time. It's called refactoring.
Yeah, sure. But this is what actually, I find this process to be quite tedious. Like every time you learn that the world is slightly more complicated than you thought, you need to change your abstractions. It's new interfaces, new virtual methods, and it's so complicated process. Then very often developers just go and just start violate Liskov. And if you look at F#, we don't need to define this virtual abstract classes or interfaces. So what we do here, again, it's another example of some type of discriminated union. So we define different funding sources, and we can pattern match on them without using any interface.
Okay, but what if different payment options they don't implement a shared interface, right? So how would I get access to individual properties of every subtype?
Well, it's a pattern matching, and the important difference is here that the definition goes. If you just go back for a second for the previous slide,
sure.
Like the definition goes in the opposite order. In C#, you always start with abstraction. Like iPayment, and then you sort of bind concrete classes towards that. So and then it makes it very hard to change things. Here in F# we define this grouping at the last time point. So our concrete classes like card details, bank account, they stay untouched and actually unaware how we group them in this discriminated union. So if we go to the next slide then here we have function which looks similarly, but we don't need, we pattern match here, and we don't need to violate anything just by going from interface to concrete implementation.
But I mean, didn't you just violate LSP here by upcasting to cache?
There is nothing to violate here because Liskov substitution principle about conformance of superclasses and subclasses. Here we don't have superclasses. And in functional programming, you do have polymorphism. You have it in so-called parametrical polymorphism. So if you send generic input to functions, then Liskov applies. But real world is more often than not truly polymorphic. So I think this reflects in a better way what we face in the real world.
Well, smart move, yeah. You cannot violate OOP principles if you don't use OOP, right? But again, it's just different, you know, it's functional, yes, it is fancy, but I can do it in object-oriented world as well.
Yeah. But I mean, maybe to strengthen my point, this example of not something which I deliberately found to look bad. This is one of the oldest .NET types. It's a type stream which is used like everywhere. And this is, it looks like it should be truly polymorphic because everything is abstract, virtual, and it supports, implements several interfaces. And then when you look at these properties, can read, can seek, can timeout, you might question that it's truly polymorphic. And in fact, every essential method can throw exception. So like we try to model things as polymorphic, and then every this exception is actually violation. So this is how polymorphism goes bad if you try to enforce polymorphic abstractions on something that is not truly polymorphic.
Well, yeah, now I see your point, and the truth is that that's not the only example of the LSP violation in the standard library, like iQueryable or collection interfaces, but I think that's convincing enough, so we don't need to cover other examples. But in defense of the .NET platform, I'd say that, well, it's as old as the .NET platform itself. So I think that if the .NET team could implement it today from scratch, they would have implemented it differently.
Yeah, sure. But other teams come with other implementations and they do same mistakes. And this is what sort of bothers me about the whole concept.
Yes, true. But on the flip side, I don't think that the specific implementation option is the problem here. The real problem, at least to me, is that there are way too many dependencies. Like almost every .NET code base that exists today, it depends on the stream class. So whether it's a discriminated union or class, it's difficult to change these kind of design decisions, regardless of the implementation option.
Mm. Okay, fair enough. I think we have probably said enough about our difference in this round, so #maybe we should go to voting?
Sure. So, polymorphism is dangerous. We really need exhaustive pattern matching in C#. That's a vote to F#. No, that's fine. We just need to make sure that we follow the LSP.
Very interesting. Also very close.
It's again so close, yeah.
Yeah. Maybe a few seconds more. Okay, so it was third round.
Yeah, two against one, 2 versus 1. Yeah, almost. I think it's safe to continue. So 2 points. C# has 2 points. F#.
No, F# has 2 points.
Oh,
is it? It's F# has 1.
Oh,
yeah.
So you are the winner, at least as of now.
Yeah, well, let's see a few rounds more.
Okay. So at the end of the last round, you saw some exceptions drawn from the stream class. So it's about time to talk about error handling in each language. And throwing exceptions is quite common in C#, and Microsoft claims that that's a best practice.
Yeah, and I think this practice has been adopted by C# developers, and this is a slide from a great talk by Scott Flashen, which is called Ravel-Oriented Programming. And this talk clearly shows that developers has learned a lot about how they should do error handling. But don't you think that one problem has turned into another?
No, I still think that it's the same problem, and it has nothing to do with exceptions or error codes. It's about the human nature. And the real problem is that exception handling or error handling is tedious and boring, and people just don't like to do this stuff. So throwing exception is a tool, and you can design and build resilient software with exceptions. But people are people, you know.
Okay, so it's a question of discipline. But what I find problematic with error handling is that it really breaks your execution flow. If you go to the next slide, where we see how it's a simplest case of exception. You have one line of happy path code surrounded by 7 lines of error handling, and that's just a simple case. So if we have a database error, now 2 exceptions, and how do we recover from the database connection? Should we reopen it? Like, clearly it becomes very complicated, and then it's really overwhelming. Like if you have multiple threads, so here exception happens in a different thread, how do you recover from that? So it really makes the execution flow very difficult.
Normally I don't copy-paste try-catch blocks across my code base. Instead, I implement global exception handling. So Poly is a specific library that comes to my mind. So if we need to have a specific example, for an HTTP client, I would rather configure an HTTP client factory. I can use Poly to enable things like circuit breakers, retry policies, and so on and so forth. And I only need to do it once during the program startup.
Who is familiar with Poly, by the way? Okay, quite a few hands.
Yeah, that's a great library if you need to learn one thing from this talk.
Yeah.
So take a look.
Yeah, I'm also familiar with poly, but we are to compare intrinsic error handling in both languages. So let's not bring external libraries here and just focus on idiomatic ways of how do we handle errors.
Well, I would still consider the language and its ecosystem as a whole, but you know what, let's continue. Let's see how it goes.
Mm-hmm. Yeah, well, again, as I said, that exception handling, it really complicates execution flow, and it is sort of admitted by people doing both C# and Java programming. Yeah, and but there are alternatives to that, and if at least in functional languages. So if we go to the next slide, I think
Okay.
this is how we do it in F#, and this is again another example of discriminated union of some type where you have a result of T and T error, so a generic type which groups two outcomes of operation execution, OK of something and error of something. And then in your code you can match, you use pattern matching to choose your next path.
Mm-hmm. Yeah, it looks good, almost like the try pattern in C#, but okay, I'm good with just a single result, but what if I needed to combine multiple results together? Mm-hmm. Would I need to write a pyramid of doom style of code like this one, match, 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 match?
Yeah, well, of course, if that would be the only way, then I would support it like exception handling. So, but you don't need, of course, to write such horrible code in F#, and you can, with support of a couple of extra functions. One is like bind, which wraps, unwraps results of execution, binds with input of function. You can use it in when defining extra operator, which looks like a fish. And here,
what's the fish?
It's a fish. It's basically it's error aware operator that lets you build your processing workflow. If you look at our original workflow, which is not error handler aware, there it will be hard to do error handling. But here it takes care of all internal things, how we parse results, extract error, what do we do next. So your workflow looks completely not completely unchanged, but the structure of workflow is unchanged.
Okay, let's postpone discussion about the mysterious operators of yours until the next round, because it will take some time. And let's check the opinion of the audience. So C# provides exception handling, and as an alternative to the result mechanism, we have the well-known try pattern, methods like pass versus try pass, and in F# we have results and .NET exceptions. So please vote. Just a note, we do use exceptions in F# as well, because F# runs on top of the .NET ecosystem, and we have a lot of exceptions drawn from the library code.
Mm-hmm. Interesting. So exceptions are clear winners here in this round. But again, it's relatively close, 60 by 40.
Yeah, throw your result away.
Yeah. So it's 2-2?
Yeah, I think so. So let's discuss the operators. And until now, we've been comparing different techniques that are applicable applicable to C# and F#. And we've been solving similar problems. And this round is quite unique because we are going to discuss a unique feature of F# that does not exist in C#. And C# addresses the same issues quite differently. And since we don't have many F# developers in this room, I think that Vagif, you need to do a brief introduction to computation expressions in F#.
Yeah, of course, I can only do it very brief without going into details, but basically that fish operator, which you called cryptic in last round, you don't need to do that. You can define your workflow using F-sharp extensions like computation expression. So here we have how computation expression called result is applied. So everything which is within the scope, it's handling of result. And you have slightly modified let operator, let bank, which means let with additional semantics. So what's hidden behind this additional semantic is that it takes care of error code, error result, and then if it's a happy path, it continues. If it's error, that it goes other way. So here we are able to extend language with extra functionality to implement different workflows. So this is an example of how result workflow works.
So in other words, let bang is a shorthand for the bind function from the previous round.
Yeah, internally you can say that, but you don't need to know that.
Yeah, and we don't need to use the fish. Okay.
Yeah.
It's quite similar actually to how async await works in C# in the sense that we have a way to kind of unwrap the wrapped value, but unlike in C#, it's not task of T, but it's result of T, right?
And you will see it on the next slide. So here is how we implement async workflow in F#. And again, it's a different semantics behind let bank, but it takes care of everything with asynchronous processing. And it looks almost identical to C# counterpart. So if you change this let bank thing with var and await, it's almost how you will get it in C#.
Yeah, however, despite that these two examples are quite close to each other, there's an important difference here because awaits here are keywords that are defined in the language itself rather than in a third-party library, while in F# we can write our own let bank stuff, right?
Exactly. So in C# you have to change the language itself. It came like with new keywords, while in F# you just extend your workflows without upgrading the language. So if we look at another computation expression, this is a query. So it's to implement link-alike operations. And so you have plenty of computation expression that comes either with F# core library or some open source libraries like akka.net, which comes with actor computation expression, and you can write your own. And this I find very powerful. And this, as you mentioned in the beginning, is something that F# has and C# doesn't. And I think it's quite important selling points for F#.
Yeah, it is. And I don't want to downplay the role of computation expressions, but we need to admit that computation expressions is a fancy way to say monad comprehensions. And we all know that monads A are evil, B are confusing, C are misleading. So for a mainstream language like C#, I think that computation expressions might be way too powerful.
Well, I didn't say the word monad. You
said bind.
I think, again, if you start writing computation expressions, yes, you need to learn more, but you don't need, and in many cases, you don't want to know the internals, and it still gives you powerful ways of extending the language. So.
But I don't need to know the internals of these keywords as well, and all of them are quite complex. Await, link, or yield, they all generate some weird stuff, and the compiler takes care about it. So at least it covers 99% of my use cases, and I'm happy with keywords. Yeah.
It's just a principle different approach to extend language with keywords, like do new version of the language, or just have a mechanism to write extensions without upgrading the language. So let's decide what is best.
Vote. So basically we have two quite different options. Either we have a really generic and powerful technique like computation expressions in F#, or we just have many keywords in C#, and the downside is that every time we need to introduce a new workflow, we have to release a new version of the language.
Okay, so I think we have a clear winner here. So most of the people in the room convinced with your argument that you basically C# by offering new keywords, give them what they mostly need.
So it's 3 versus 2, right?
Yeah, it's 3 versus 2, and we have now final round, I guess.
Yeah, the final one, and we are going to wrap up our presentation with this one. Yes, true, F# is a great language, and some of its features, like computation expressions, might be the deciding factors for some teams. But how many of them? How many people use F#? On the screen, you can see the results of the most recent Stack Overflow developer survey, and it shows a huge gap in popularity between C# and F#, and that's kind of a gap to be reckoned with.
Well, it's a huge gap, I agree, but before we address that, why do you think it's important? Like you choose your language, you work with that. I mean, SQL actually has more popularity with C#.
It's even worse. Take a look at the first.
Or JavaScript. Yeah. So why do you need to care much about that?
Well, maybe it's my internal manager speaking, but hiring a good engineer is a challenging task in itself, and hiring a good engineer who knows F# sounds even more challenging.
Yes, I see your point. What we found in our team and through the lifetime of our project, that we don't hire F# developers. We try to hire good developers and people with passion, and it always worked out. We even hired once a developer for our F# project with no F#, no C#, no .NET, and no Windows experience. He had C++ experience from embedded systems, and he became a great developer because he was interested in functional programming, and he quickly learned. So I think it's not a crucial point. It's not a crucial factor.
So you don't agree that it might be a concern, or do you?
Well, I agree that it's a concern for management, of course, and then like for me also. And I wish, of course, that F# community was larger, but I think that should not stop you from going that path if you really like the language and want to implement your project on it.
Okay, so let's see what the audience think about it. Should the size of community be the deciding factor, yes or no?
That's okay, 65-35. C# is going ahead, but not with. Oops.
Wow. What do we do if we end up with 50-50?
More words? we are not qualified to vote. Okay. Yeah, 5 more seconds.
But it was so close. Yeah. I didn't see it.
50-50.
Really? Really?
Well, I think that...
Just 1 point ahead, right?
Yeah.
4 against 3.
What does it tell us? It tells us that we have even number of people in the audience.
Yeah, it's so cool. Oops. No. Oh, yeah. Okay.
Okay. F#.
Oh, no, it's F#.
3-3?
Yeah.
We need to have odd number of rounds, so we have a winner. But that was very interesting because that round actually it was meant as like clear winner for C#, and I'm really glad that you are open-minded in that respect. That you think that if you have a passion for some technology, then you should actually go for that. And so what can we conclude?
Yeah, and actually that's a conclusion we wanted to have from this talk. It's not like C# or F# is better than another. These languages are both great languages, and you can write in both of them. You can learn both of them. Actually, that's what I would recommend you to do. And many teams have chosen C# and F#, and they are all right with their choices, and more importantly, they're happy with their choices. So we really appreciate your activity today, your votes.
Yeah, and also we tried, and the main goal for our presentation was to provoke some thoughts, to let you explore the language you work with. Actually, we learn about languages we mainly use every day. Also to explore opportunities around you.
And thank you for being so impartial today, and happy coding.
Yeah, and thank you for being fair judges.
Thank you very much. If anyone has questions, we have a time for a couple of them.
Yeah. Any questions?
Or you can catch them later in the break if you want a private conversation. Also understandable. I just have one question.
Oh, there is a question.
Okay, I just have a question for everybody. Like, did anyone actually change their mind about something during this session? Nah, everyone's stubborn.
Will you quit your job?
Okay, what's your question?
Thanks a lot. Thanks a lot for the talk, amazing discussion. I was wondering if there is a difference where you would go for C# or where you would go for F#.
Okay, let me say first, maybe we have also different opinions on that. It used to be, like 5-7 years ago, oh, F# is great language for scientific stuff, for financial. But that is no longer true. Actually, it was not true at that time. For example, in our project, we have a system based on actor model, which uploads media files into the cloud. So it has to be highly scalable and available. So it's a lot of multi-threaded processing, and it's all done in F#. And we have also web services written in F#. And we appreciate like how we can model our domain. We have very clear domain model, which is easy to maintain and change. So I think F# is applicable to everything, but ecosystem is better for C#. You have better tools typically, so that might be the difference. Yeah, Max, would you?
Yeah, I can add something. The beauty is that you don't have to choose one, because these both are .NET languages, and it's perfectly fine to have some subsets of your applications written in F#, for example, and one can expose the F# part of the application via a facade with like interfaces, and interfaces might be the way to go. And once you enter the F# world, you can use records, you can use pattern matching and things like that. But from the C# side of things, your code base, your facade would look like as if it was written in C#.